All right, Professor. So I'm doing my recordings for the assignment, and I'm using Notepad, and I have the questions here. So this is going to be question one, and this is going to be question two, and this is going to be question three. So I might have them in different videos, and this is question one: electric charge and electric fields in chapter 16. I have the PDF version, and the PDF version is it has it in different chapters. So my chapter is chapter 21, and number number 49. So I'm taking this question. I just screenshot the question and put it here so I can work it out and have the working alongside the question, and I can upload it. So I'll just go ahead before I talk too much. All right. So this is the question. It says a thin rod bent into the shape of an arc of a circle of radius r, which we can see, and a uniform charge per unit length of I call a lambda. I don't know what that is. I forgot that name. But the arc subtends a total angle of 2 times theta, symmetric. So let me see. Wow, I am going to switch this off. There's a video. So selection down while center. Okay. Sorry, this is my first time using this software, so I wanted to do something and I wasn't so what button to press. But anyway, I'm just gonna continue on the question. I already worked it out, so now I'm gonna write it and then I explain it like how I get it. So it says we're going to select a differential element of the arc which makes an angle of theta with the x-axis. The length of the element, let's say we draw it like this. Oh my god. Alright, I'm gonna bring this one. Say if we draw it like still coming. Okay, put this on and then put this, yeah. So let's say if we redraw this like this, and then we have the x-axis this way. No, we have the x-axis this way, and we go like that. X. So we're going to have we're going to work on this side. Let me use the cursor. We're going to work on this side, and then the answer will be the negative, the whatever the sign is, the answer. We just check the opposite of that for that to be the electric field. So this is going to be R. Oh man. This is going to be R times the distance times theta, and then this we're gonna have another one here. This is going to be theta, and this is going to be the symmetric, the other one. So we're going to have what this is going to be the d, the distance, times the electric field, times E, and then this is going to, that is the bottom, this is the bottom one, B O M, the bottom. That doesn't look good, so I'm just gonna put BTM, but just for bottom, BTM for bottom, and this is going to be the distance times the electric field for top, OP, because this here comes this way, and then this one here comes down that way. All right, so now from the diagram, considering pieces of the arc that are symmetric with respect to the x-axis, we see the total field will only have an x component. So the total electric field will only have an x component. So therefore, the vertical component of the field will cancel each other, like the top and the bottom components will cancel each other because it's symmetric. And in that case, we will have the equation we're going to use is going to be I'm going to use, let me see, the equation we're going to use is going to be, what is it, I'll start from here as d of E is equals to 1 all over 4 pi epsilon naught, okay, and that multiplied by lambda times the radius times d times this, like lambda multiplied by this right here, multiplied by this, okay, and then cos that divided, oh man, that divided by the r square, and then cos of theta. So this is going to be E horizontal, the electric field horizontally, HORI. Anyway, so E horizontal, the electric field, the horizontal electric field. So I'm going to move this up a little bit, or maybe get a new page. This is full. Yes. That is going to be the same thing as that's going to be the same thing as E. Oh. Plus. So to get rid of the D on this side, on the and get E by itself, the electric field by itself, we go E horizontal is equal to the integral of what is it? Integral from this angle. Where is it? No. The integral from, like, for the whole of these angles here, because this one is in negative and this one is in the positive, so the integral of those ones. So we go okay, from the integral of that positively to the negative integral. Of 1 all over 4 pi epsilon 0, cos cost of theta multiplied by lambda radius times distance times theta all over radius square. That cos, yeah, so that will also be the same thing as, that is equal to, no, that is equal to, again, so since we took the integral of that, we could bring the lambda times the, actually no, let me just take that off. Actually we could cancel this here, we could cancel this r here, and then this r will be just 1 r. Yeah, so I'm going to take this r off. Lambda times d you can have lambda divided by 4 pi epsilon naught. Then you have one single r now, times the integral of 0 plus of cos of cos theta times the distance times theta, and this is the same thing, that is the same thing as, that's the same thing as where is it, lambda all over 4 multiplied by sine of theta minus sine of negative 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 theta. To take the integral of So which is also going to be the same thing as this is equal to that is equal to what? 2 times lambda times sine of theta 0 divided by 4 pi epsilon naught r, and then we can cancel this by this, and we have 2 here. So since we are solving for E, since this is E and it is on the negative side of the horizontal of the x-axis, for example, it is on this side, put that in red. Since E is on the negative side of the negative x-axis, the electric field that we're solving for is going to be the opposite of that sign. It's going to be the opposite of that sign, and therefore this, it was in the negative side, so this is going to be negative. Actually no, that doesn't make it negative. What makes it negative is my fault. What makes it negative is here, these signs here, we multiply this sign here, so that we have a negative sign, we have a negative answer here. So therefore the final E is going to be positive instead of negative. Yes, so that was right, because the two signs also cancel each other, negative signs cancel each other. So this is going to be our answer for number 46. Thank you. For number 46, no, 49, number 49 of chapter 21, the PDF that I'm using, which is chapter 16 of the class, of the book that we're using in class, electric charge and electric fields. So this is my answer. I'm going to bring it down. This is it. Thank you. I'm gonna stop it here because it's gonna be long if I want to put all the 3 videos. So stop this.